So I'm inside the 777X mock-up at the Paris Air Show.
I'm out here to catch the 777X. It's coming in momentarily for the Dubai Air Show.
Boeing is about to bring something genuinely game-changing to the skies. The 777X isn't just another aircraft rolling off the production line, it's a statement about where long-haul aviation is headed, built around technologies that didn't exist a decade ago.
So behind me is the wing of the 777X. It's an all-composite wing, and you'll notice above me it's a folding wingtip.
Folding wingtips, the world's most powerful jet engine, and a wing so advanced it required entirely new manufacturing methods. This is the aircraft that could define international travel for the next 2 decades. So what makes it so different? And why does 2026 matter so much? The 777X program origins. The story of the 777X begins not with blueprints, but with a problem. Airlines loved the 777, especially the 300ER variant, which became the backbone of long-haul operations worldwide. But as fuel prices climbed and environmental pressure mounted, carriers needed something better. They wanted the same capacity, the same range, but with significantly lower operating costs. Simply tweaking the existing 777 wouldn't cut it. Boeing faced a choice: develop an entirely new aircraft from scratch or push the 777 design further than anyone thought possible. They chose the latter, but with a twist. The 777X would borrow the fuselage diameter and basic layout of the original 777, but almost everything else would be new. New wings, new engines, new systems, new cabin. It was ambitious, maybe even risky, but it addressed what airlines actually wanted. The program officially launched in 2013 after Boeing secured commitments from major carriers. The timing was critical. Airbus had just begun delivering the A350, a clean-sheet design that threatened Boeing's dominance in the wide-body market. Boeing needed a response, and the 777X was it. Unlike the 787, which faced years of production delays and technical challenges, the 777X was designed to leverage Boeing's hard-earned lessons. It would use proven manufacturing techniques where possible, but introduce cutting-edge technology where it mattered most. 2 variants were planned from the start, the 777-8 for ultra-long range and the 777-9 for high-capacity routes. This dual approach gave airlines flexibility while keeping development costs manageable. The goal wasn't to reinvent commercial aviation, but to make it dramatically more efficient without sacrificing what passengers and airlines valued most: composite wings and folding wingtips. If you want to understand why the 777X matters, start with the wings. They're not just bigger than the original 777's wings, they're fundamentally different. Constructed primarily from carbon fiber reinforced polymer, these wings represent the largest composite wing structures ever built for a commercial airliner. Composite materials offer a better strength-to-weight ratio than aluminum, which means the wings can be longer and more aerodynamically efficient without adding excessive weight. And they are longer, significantly so. The wingspan stretches over 235 feet, making it wider than any current commercial jet. That extra span translates directly into better fuel efficiency through improved lift-to-drag ratio. Longer wings generate lift more efficiently, reducing the fuel needed to keep the aircraft airborne during cruise. It's basic physics, but executing it at this scale is anything but basic. Here's where things get interesting. A wingspan that large creates a practical problem. Most airports aren't designed for it. Taxiways, gates, and parking areas have width limits. An aircraft too wide simply can't operate at many facilities. Boeing's solution was audacious and elegant: folding wingtips. The outermost sections of each wing, roughly 12 feet, hinge upward when the aircraft is on the ground. It's a mechanism borrowed from naval aviation, where carrier-based aircraft fold their wings to save space, but never before used on a commercial wide-body jet. The engineering behind this system is fascinating. The hinge mechanism must be robust enough to handle the stresses of flight, light enough not to negate the wing's weight savings, and reliable enough to meet aviation's demanding safety standards. Sensors ensure the wingtips are locked in place before takeoff, and the system is designed with multiple redundancies. During flight, those wingtips stay firmly extended, contributing to the wing's overall efficiency. On the ground, they fold up, allowing the 777X to fit into the same gate space as a standard 777. This isn't just clever engineering for its own sake. It solves a real operational constraint while allowing Boeing to optimize the wing for aerodynamic performance rather than airport compatibility. The result is an aircraft that behaves like a much smaller plane on the ground, but flies with the efficiency of something purpose-built for ultra-long range. The GE9X engine revolution. Mounted under those massive wings are two of the most advanced engines ever certified for commercial service, the GE9X. These aren't just big engines, they're genuinely revolutionary. With a fan diameter of 134 inches, each GE9X is wider than the fuselage of a narrow-body airliner. That enormous fan is part of what makes this engine so efficient. Jet engine efficiency largely comes down to bypass ratio, the amount of air that flows around the engine core versus through it. Higher bypass ratios mean more thrust from less fuel. The GE9X achieves a bypass ratio higher than any previous wide-body engine, moving massive volumes of air with each rotation. That translates directly into lower fuel consumption per pound of thrust. For airlines, that means lower operating costs. For passengers, it means quieter engines. But size alone doesn't explain the GE9X's performance. GE incorporated materials and manufacturing techniques that were experimental just a few years earlier. The engine's hot section uses ceramic matrix composites, materials that can withstand extreme temperatures while weighing less than traditional metal alloys. This allows the engine to run hotter and more efficiently without requiring additional cooling air, which would reduce overall efficiency. The fuel nozzles inside the GE9X are 3D printed, a manufacturing technique that allows for complex geometries impossible to create through traditional machining. These nozzles atomize fuel more efficiently, leading to more complete combustion and lower emissions. It's a small component, but it demonstrates how the GE9X integrates advanced manufacturing throughout its design. GE spent years testing this engine under conditions that would never occur in normal service. They ran it at maximum power for extended periods, subjected it to extreme temperatures, even fired ice and debris into the intake to simulate worst-case scenarios. The engine had to prove it could handle anything before it would be certified to carry passengers. That certification process was exhaustive, but it ensured that when the GE9X entered service, it would be as reliable as it is advanced. For Boeing, partnering with GE on the GE9X was strategic. The engine's efficiency numbers are critical to the 777X's value proposition. An airframe can only do so much. The engines must deliver on their promises for the entire aircraft to succeed. Cabin design and passenger comfort. Once you're past the wings and engines, there's still the matter of what happens inside. The 777X cabin represents a significant step forward in passenger experience, particularly on the ultra-long flights this aircraft is designed for. Boeing redesigned the interior with a focus on the small details that matter during a 15-hour flight. The fuselage diameter remains the same as the original 777, which gives the 77X the widest cabin of any twin-engine airliner. That extra width translates into more personal space, wider seats, and broader aisles. It's a tangible difference, especially in economy class where every inch counts. Airlines have flexibility in how they configure the interior, but the extra width gives them options that narrower fuselages simply don't allow. Windows are larger than on previous 777 models, offering better views and more natural light. It's a subtle change, but studies show that natural light and visual connection to the outside reduce passenger fatigue on long flights. Boeing also redesigned the cabin lighting systems, using LEDs that can simulate different times of day. This helps passengers adjust to new time zones and reduces the disorienting effects of crossing multiple time zones in a single flight. Air quality received significant attention. The 777X maintains a lower cabin altitude and higher humidity than older wide-body aircraft. Lower cabin altitude means passengers experience less of the fatigue and dehydration associated with long flights. Higher humidity has similar benefits and makes the cabin feel less dry and uncomfortable. These improvements come from better air handling systems and materials that can tolerate higher moisture levels without corroding. Noise levels are also reduced. The advanced airflow design around the fuselage and the quieter GE9X engines mean the cabin is noticeably quieter than previous generation widebodies. On a long flight, that reduction in background noise makes a real difference in passenger comfort and the ability to rest. All of these improvements might seem incremental individually, but together they create a noticeably better experience. For airlines operating ultra-long routes, passenger comfort isn't just a nice-to-have, it's a competitive advantage. Performance metrics and range capability. Numbers tell part of the story, and the 737X's performance figures are impressive. The 777-9, the larger of the two variants, can carry over 400 passengers depending on configuration, with a range of around 7,285 nautical miles. That's enough to connect almost any two cities on Earth with a single stop, and many city pairs non-stop. The 707-8, optimized for range over capacity, pushes even further. With a slightly smaller passenger count, it can fly over 8,700 nautical miles. That range opens up routes that were previously impractical or required fuel stops. Airlines can now consider direct services between cities that were never economically viable before. But range and capacity are only part of the equation. What matters to airlines is operating cost per seat. This is where the 707X's efficiency improvements compound. The composite wings reduce drag. The GE9X engines burn less fuel. The advanced systems reduce maintenance requirements. Together, these improvements deliver a per-seat cost that's significantly lower than the aircraft it replaces. Fuel efficiency also has environmental implications. Aviation is under increasing pressure to reduce emissions, and while the 707X isn't a zero-emission aircraft, it represents a meaningful step forward. Lower fuel burn means fewer emissions per passenger mile. For airlines facing regulatory pressure and public scrutiny, that matters. The 707X also excels in operational flexibility. It can operate from the same airports as the current 777, requires similar ground handling equipment, and integrates into existing airline operations without major infrastructure changes. That compatibility reduces the barriers to adoption and makes it easier for airlines to transition their fleets. These performance metrics aren't theoretical. They're based on extensive flight testing, computer modeling, and real-world operational data. Boeing had to prove every claim before airlines would commit billions of dollars to purchasing these aircraft. Certification challenges and testing. Bringing a new aircraft to market isn't just about building it, it's about proving it meets every safety and performance standard regulators demand. For the 707X, that process has been extensive and at times challenging. Certification involves thousands of hours of testing, both on the ground and in the air, to validate every system and demonstrate that the aircraft can handle any situation it might encounter in service. The folding wingtip mechanism required particular scrutiny. It's a novel system, and regulators needed to see proof that it would function reliably under all conditions. Boeing conducted repeated cycle tests, folding and unfolding the wingtips thousands of times to simulate years of operational use. They tested the mechanism in extreme temperatures, high winds, and with various failure scenarios to ensure redundancy and safety. Flight testing pushed the aircraft to its limits. Test pilots flew the 707X through extreme maneuvers, tested its performance at high altitudes and in hot conditions, and validated its handling characteristics across the entire flight envelope. They intentionally created situations that would never happen in normal operations, just to prove the aircraft could handle them. One challenge that emerged during testing involved the GE9X engines. While the engines themselves performed well, integrating them with the airframe revealed unexpected interactions that required adjustments. These kinds of discoveries are exactly why flight testing exists, to find and fix issues before passengers ever board. Regulatory scrutiny intensified following the 737 MAX challenges. Certification authorities worldwide became more cautious and thorough, demanding additional data and testing beyond what previous programs required. For Boeing, this meant more time and more documentation, but it also ensured that when the 777X finally receives certification, it will have been examined more thoroughly than almost any aircraft in history. Boeing also faced production challenges. The composite wing manufacturing process, while proven in principle, had to be scaled up to produce wings at the size and rate needed for commercial production. Supply chain issues, labor challenges, and the broader disruptions from global events all impacted the timeline. But these challenges, while frustrating, are also part of developing cutting-edge technology. Every issue identified and resolved makes the final product better. The delays, though costly, ensure that when the 707X enters service, it will be ready. Strategic value for airlines. For airlines, the decision to order the 777X isn't just about having the newest aircraft. It's a strategic calculation about long-term fleet planning. The 777X offers a unique combination of capacity, range, and efficiency that fits a specific operational niche: high-demand, long-haul routes. Consider a route like Dubai to Los Angeles or Singapore to New York. These are ultra-long flights with enough demand to fill a large aircraft. The 707X allows airlines to serve these routes with fewer flights while maintaining high passenger counts. Fewer flights mean lower crew costs, reduced airport fees, and better utilization of limited airport slots. In slot-constrained airports, where takeoff and landing rights are scarce and expensive, the 777X's high capacity per flight is particularly valuable. An airline can move more passengers through a single slot, maximizing revenue without increasing frequency. This is a key competitive advantage in markets where expanding flight numbers simply isn't an option. The 777X also serves as a replacement for aging 777-300ER aircraft, many of which are nearing the end of their economic service lives. Airlines that invested heavily in the 777 family have a natural upgrade path to the 777X. The operational similarities mean reduced training costs, compatibility with existing maintenance infrastructure, and continuity in fleet planning. For flag carriers and major international airlines, the 777X is also a prestige aircraft. It represents the forefront of aviation technology and offers a premium product that differentiates them from competitors. In markets where brand and passenger experience matter, flying the latest, most advanced aircraft is a tangible advantage. But the 777X isn't for every airline. Its size and range make it ideal for specific missions, but smaller carriers, or those focused on point-to-point rather than hub operations, may find other aircraft better suited to their needs. Boeing understands this, which is why the 777X exists alongside the 787 and other wide-body options in their lineup, industry competition, and market positioning. The 777X doesn't exist in a vacuum. It competes directly with Airbus's A350, particularly the A350-1000 variant. Both aircraft target the same market: high-capacity, long-haul routes where efficiency and passenger experience matter most. The competition between these two aircraft shapes how airlines approach fleet renewal and route planning. The A350 entered service years before the 707X, giving Airbus a head start in capturing market share. Airlines that needed new wide-body capacity couldn't wait for the 777X, so many ordered the A350. That early entry gave Airbus valuable operational data and allowed them to refine the aircraft based on real-world airline feedback. But the 777X has advantages of its own. Its larger capacity, particularly in the 777-9 variant, offers airlines a way to move more passengers per flight. On dense routes where demand is consistently high, that extra capacity translates directly into revenue. The 777X also benefits from continuity with the existing 777 family, making it a natural choice for airlines already operating those aircraft. Pricing and operating economics ultimately drive airline decisions. Both aircraft offer significant efficiency improvements over previous generation widebodies, but the specifics vary depending on route structure, load factors, and fuel prices. Airlines run detailed financial models comparing the two aircraft for their specific operations, and the winner often depends on factors unique to each carrier. Beyond Airbus, Boeing also faces the reality that some airlines are delaying wide-body purchases altogether. The economic disruptions of recent years led many carriers to defer fleet expansion, opting to extend the service lives of existing aircraft rather than commit to new orders. This has slowed the wide-body market and made every sale more competitive, Yet the fundamentals remain strong. Long-haul travel continues to grow, driven by rising global connectivity and expanding middle classes in Asia and other regions. Airlines need aircraft capable of serving these markets efficiently, and the 777X is designed precisely for that mission. As the market recovers and airlines resume fleet modernization, Boeing expects the 77X to capture a significant share. The competition isn't just about aircraft specifications, it's about delivery timelines, financing options, after-sales support, and the broader relationship between manufacturers and airlines. Boeing's challenge is to demonstrate that the 777X delivers not just on paper, but in daily operations. The 2026 timeline and entry into service. So why does 2026 matter? It's not just a date on a calendar. It represents the culmination of years of development, testing, and certification. By 2026, Boeing expects the 777X to be fully certified and entering regular airline service. This timeline reflects the realities of bringing such a complex aircraft to market, especially given the additional scrutiny and testing required in today's regulatory environment. The path to 2026 involves several critical milestones. Final certification must be obtained from aviation authorities in the United States and internationally. Airlines need time to prepare their operations, train crews, and integrate the aircraft into their schedules. Maintenance programs must be established, spare parts stocked, and ground handling procedures finalized. All of this takes time. For Boeing, 2026 also marks a turning point in production. The initial aircraft deliveries will go to launch customers, airlines that placed orders early and have been waiting years for their jets. As production ramps up, Boeing can begin fulfilling the backlog of orders and demonstrating that the 777X can be built at scale, reliably, and profitably. Airlines are watching closely. The success of the 777X in its first years of service will influence future orders not just for this aircraft, but for Boeing's entire wide-body lineup. Early operational performance, reliability, and customer satisfaction will shape the aircraft's reputation and determine whether additional airlines join the program. 2026 also aligns with broader trends in aviation. The industry is recovering from recent disruptions. Long-haul travel is rebounding, and airlines are once again looking toward fleet modernization. The timing positions the 777X to meet renewed demand just as carriers are ready to invest in new aircraft. But timelines in aviation are always subject to change. Unexpected technical issues, regulatory delays, or supply chain disruptions could push dates further. Boeing has learned hard lessons about overpromising and under-delivering, and the company is taking a more measured approach with the 777X. The focus is on getting it right, not just getting it done quickly. If 2026 goes as planned, it will represent not just the entry into service of a new aircraft, but validation of Boeing's approach to next-generation wide-body design. It will show that evolutionary improvements, applied with cutting-edge technology, can deliver the performance airlines need without the risks and costs of an entirely clean-sheet design. The 777X represents more than advanced engineering or impressive specifications. It's Boeing's answer to a fundamental question: what comes next for long-haul aviation? As the industry navigates pressures around efficiency, capacity, and sustainability, the 777X offers a vision of how wide-body aircraft can evolve without starting from scratch. Whether it reshapes the competitive landscape or simply holds the line against Airbus depends on execution, timing, and the unpredictable realities of global aviation markets. But one thing is certain: when those folding wingtips unlock and the GE9X engines spool up for the first commercial departure, it will be a moment the industry has been waiting years to see.